Hello everybody, this is Dr. Christopher White and welcome back for part 2 of our video dealing with the lab exercise correlation. So we've moved on to part 1 of the lab exercise and this is going to deal with physical correlation of strata. So following the field work in an area, the lithological data for all the outcrops visited will be collected and they will be used to produce a stratigraphic section for each of those locations. And remember, those locations can be either outcrops where you have rocks visible at the surface, or they could be boreholes. Now, what geologists will then aim to do is they will correlate the stratigraphic columns between different adjacent locations. And they will do this to produce a model for the subsurface between the locations which you are trying to correlate. Now, what we're going to be doing in part 1 is arguably the most basic form of correlation, which is when you are linking up layers of rock from adjacent locations. So in order to do this, we are simply going to be working out which layers of rock match up with each other and then connecting them at their upper and lower boundaries. So obviously, as we've already touched on a few times before, when you are progressing laterally from one location to another, the layers of rock don't always stay the same, so you may lose layers of rock, you may gain layers of rock, or you may have one layer of rock that transitions into a different type of rock. So what we're going to do is we're going to look at a few examples of how we are going to draw these changes when we are correlating between two different locations. So over here on the right, you can see we have 3 different diagrams showing how we will draw changes in the lithologies between our locations. So we're going to start here in the top left with diagram W. So in diagram W, you can see we have stratigraphic columns to 2 locations, 1 and 2. And you can see that at location 1, we have 5 lithologies, and at location 2, we have 4 lithologies. So straight away, there is a marker bed that we can use. You can see down at the bottom here, layer of rock A at location 1 and layer of rock 1 at location 2 are clearly the same layer. So straight away, what we will do is we will draw a line which links the bottom of that unit and the top of that unit, and we have correlated those rocks straight away. Now, then what we're going to do is we are simply going to use the pattern of the layers of rock to guide us. So for instance, if we look at location 2, we can see we go from this layer at the bottom, then we have a sandstone, a mudstone, followed by a sandstone. At location 1, we have a sandstone, a limestone, a mudstone, and a sandstone. So what we're going to do is we're going to say, right, well, clearly these two layers, these layers at the 2 locations link together. And then above them, we have a sandstone. So that would suggest that layer B should correlate to layer 2. And then above layer 2, we have a mudstone. Well, that would suggest the mudstone should correlate to D. And then above the mudstone at both locations, we have a sandstone again. So that would suggest that E should correlate to rock 4. Now, obviously, you can see we do have a rock layer that disappears between the 2 locations. So at location 1, we have this limestone. So how are we going to draw in our diagram to represent this limestone disappearing between our 2 locations? Well, once again, remember we are linking together the top and the bottom of the correlating layers. So for layer B and layer 2, we will correlate across the bottom, and then we will correlate the top. So we will link the top of layer B to the top of layer 2. We will then correlate layer D with 3. So we'll do the bottom of layer D, the bottom of layer 3, and the top of rock D to the top of rock 3. And in the process of doing that, you will see that we will end up creating a triangle, which in this diagram is marked out as red. And so what this triangle is doing, as you can see, as you move from location 1 to location 2, the triangle is getting thinner as you move towards location 2. And this on our diagram essentially says layer rock C is thinning and eventually pinching out between our 2 locations. And so that's how we would represent that kind of change in a diagram. Now, let's say we have a situation where we have 2 layers of rock which are pinching out. So we have a very similar situation here, but now we have 6 layers at location 1 and we still have 4 layers at location 2. So in this case, you can see layers C and D do not occur at location 2. So clearly they are pinching out as you move between the locations. So once again, we are going to link the bottom of B 2 and the top of B to the top of 2. We're going to do the same thing with E. We're going to link it to 3. So bottom and top. And once again, we end up creating a triangle just like we did in diagram W. Now in this case, what we're going to do is we are simply going to draw a line from the point where layers C and D meet. And we're going to take that line and we're going to draw it to the peak of the triangle over here on the right. And so by doing that, we're taking our larger triangle and we're splitting it into 2 smaller triangles, which are marked out as the red and the green. I should point out, by the way, the colors are purely there to make it clear to you. You don't have to do any coloring in when you're doing your correlation. So as we can see, we end up with 2 triangles, and each one of these triangles represents that layer thinning and pinching out as you move from location 1 to location 2. So the next thing we're going to deal with is a layer turning into a different rock type. So here we have location 1 and location 2 again. You can see A links to 1, B links to 2, D to 4, and E to 5. Relatively simple correlation. However, when you look at location 1 and 2, you will see that at location 1 you have a limestone, and at location 2 you have another rock. Let's just for argument's sake say it's a shale of some kind. So what's happening? Well, clearly, as you transition from location 1 to location 2, the limestone is disappearing, and as you move from location 2 to location 1, the mudstone is disappearing. So how are we going to draw that? Well, once again, we're going to link the top and bottom of layer B to layer 2. So we're going to link bottom and top, and then we're going to do the same for D. We're going to link the bottom to 4 and the top to 4. Now, then what we have is we then obviously have a rectangle here where we have C and layer 3 correlating to each other, but they're not the same layer of rock. They actually probably are the same layer of rock, but we're not certain about this. So what we're going to do is we're going to take a line, which we're going to take from the bottom of C, and we're going to draw it to the top of layer 3. And once again, we're going to produce 2 triangles. So we're going to have this red triangle representing layer C and this purple triangle representing layer 3. And so what these triangles are once again representing is that these layers are thinning and pinching out. But you can also slightly adapt the line that you draw here, and it can suggest a different thing to a geologist. So if you were to take this line, instead of drawing a straight line, you would draw it as a sawtooth or zigzag. That would actually represent that layer C and layer 3 are either intermingling with one another as they transition from layer C to layer 3, or it can also be used and interpreted as layer C is grading into layer 3. So if you see a correlation of stratigraphic columns between locations, and you see a zigzag pattern linking 2 layers of rock together, this can often be interpreted as either these 2 layers interbedding with one another at a midpoint, or it can be interpreted as one layer grading into the other layer. So in this case, you could interpret it as the limestone is grading into the mudstone. And that's the kind of thing we see in coastal environments. So if you think of a coastline, along the coast itself, you typically have quite a sandy environment. And then as you progress into deeper water, you move into muddier conditions. And then eventually, if the water is clear and warm enough, you will then move into a limestone environment. And typically, the boundaries between these different facies will be gradational. So there won't be a sharp cutoff between them. And so if you were to look at a stratigraphic column, for instance, you would see, for instance, if you had a limestone environment, you were going into shallow water, you would see it transitioning into a mudstone. Now, the final problem is what we have in diagram Z. So the diagram Z, what we have is we have a sequence of rocks. So we have obviously layer A and layer 1 at the bottom. Now that's our marker horizon. We can link that together very safely. Now, then we have a situation where we have 3 sandstones and 2 mudstones at location 1, and 2 sandstones and 1 mudstone at location 2. So straight away, we obviously have ourselves a problem, because we're going, well, which sandstone links to which sandstone and which mudstone links to the other mudstone? Now, in this situation, what we would typically do is we would use the order of the rock. So we'd say, right, here's our marker horizon. That's followed by a sandstone, followed by a mudstone, followed by a sandstone. So typically, we would correlate B to 2, C to 3, and D to 4. That's what we would do under normal circumstances. However, we can't be 100% certain. So what could actually happen is B could correlate to 2, C could correlate to 3, and then maybe D and E pinch out, and it's actually F that correlates to 4. So how are we going to be able to work out which layers should correlate together? Well, we're going to fall back on fossils. So as you can see in diagram Z, we have 2 fossils present in our sequence. We have this star-like fossil and this donut-shaped fossil. And you can see at location 2, here they are again, star fossil and donut fossil. And so the fact that these 2 layers share the same fossil suggests to us that these fossils are contemporaneous, and therefore so are the layers. And so that means we can then link or correlate C to 3 and D to 4, because those layers share the same rock type and they share the same fossil. So that would strongly suggest that they are contemporaneous with each other, and therefore that means that between location 1 and location 2, layers E and F are clearly pinching and thinning out and disappearing. Now, when we are correlating layers using fossils, once again, the thing we're really going to focus on is we want fossils that have a very short range. So the best type of fossil for this kind of situation is a fossil that just occurs within 1 layer of rock. So if you imagine the star-shaped fossil only occurs in this layer of mudstone, well, that means that when you go to another location and you find that star-shaped fossil, once again, that means you can correlate those 2 layers of rock together with a very high degree of certainty, because that fossil was only around for a relatively short period of time, geologically speaking. So let's move on to the first part of part 1. So I'm actually just going to drop down to question 1 here. So for question 1, we're going to use the lithologies and fossils present in this figure here, and we are going to correlate the stratigraphy between adjacent locations. So when we talk about adjacent locations, we mean we are going to correlate location 1 to location 2, location 2 to location 3, and location 3 to location 4. Now straight away, you can see when you look at these 4 stratigraphic columns, there is clearly a rock at the top here, which is purple. Typically, you would think that would be a dolostone of some kind, so a dolomite rock. So as you can see, this is clearly going to be our marker horizons. This is going to allow us to work out where we are. So you're obviously going to begin by correlating the purple layer between location 1 and 2, 2 and 3, and 3 and 4. So obviously you're going to link the top of the layer and the bottom of the layer between the locations, and therefore you will correlate the layers as you go across. Now, beneath this marker horizon, you will see we have a sequence of sandstones, mudstones, and limestones, and it's pretty messy. Notice that the sequence is highly changeable between different locations, and as such, it's quite difficult to work out which layer correlates to which other layer. So for instance, here we have this big thick limestone layer at location 1. Well, at location 2, does this layer correlate to this layer of limestone or this layer of limestone? We're not really sure. Then from location 2 to location 3, which one of these layers correlates to this thick layer of limestone here? So it's very difficult to make that correlation because we are uncertain. So the only way we can do it is by looking at the fossils. So for instance, if we are looking at this star fossil down here, you can see that it occurs in a layer of mudstone. Now, when we move over to location 2, you can see at the bottom of the stratigraphic column, you have 2 layers of mudstone separated by a thin layer of sandstone. Now, you'll notice that this lower mudstone layer, once again, it has that star fossil. And so what we can do is we can use the fossil and say, right, this mudstone here correlates with this thin layer of mudstone at the bottom. So we're going to link the bottom, and then we're going to link the top. Okay. Now then, as we move from location 2 to location 3, well, we can see there's that star-shaped fossil again. So it means this layer of mudstone correlates to this layer of mudstone. So we're going to link the bottom, and then we're going to link the top. And then finally, as we move from location 3 to location 4, you will notice that this mudstone does not contain the star-shaped fossil. And so that would suggest that this mudstone is not correlating to this mudstone here because it doesn't contain the fossil. And so that would suggest that this mudstone layer here is actually thinning and pinching out as you move from location 3 to location 4. So when you are drawing this first diagram, please, if you are doing it by hand, use a ruler to draw the lines. And remember that when you correlate layers together, so let's say we are correlating this contact here between the limestone and the sandstone. If you were to correlate from here to here, the line you draw, well, that would represent the top correlation for this limestone layer, but also the bottom of the sandstone. So you don't need to draw the line twice. You can just draw it once, and that represents the same thing, the top of the limestone and the bottom of the sandstone. Also, when you are correlating these layers together, correlate the layers that are easy to do first. So for instance, here we have a layer of sandstone which contains this square-shaped fossil. Here is another layer of sandstone with the square-shaped fossil. That means they're going to correlate with each other. So you're going to link the bottom to the bottom and the top to the top. So do all the easy ones first. And then when you're doing that, and once you've correlated all the easy layers together, you will start to see these triangular shapes appearing. And that's going to show you which layers are pinching out and disappearing between locations. Okay, so question 1, relatively straightforward. So on to question 2. So question 2 is going to ask us to deal with a more complex situation. So for question 2, we have 4 stratigraphic columns, and this is real world data that we're dealing with now. So here we go. So as you can see, there is a lot going on here. So for each of these columns, we have location 1, location 2, and then on the next page, we have location 3 and location 4. Once again, we will be correlating adjacent columns. So you will correlate the rocks at location 1 to location 2. You will then correlate the rocks at location 2 to location 3 and correlate from location 3 to location 4. Now, you may notice that as they're on 2 different pages, that's going to make things a little difficult. So how are you going to do that? Well, first of all, if you are just printing these diagrams off and doing it by hand, just use a couple of paper clips to hold the 2 sheets together, and then you can draw the lines of correlation between location 2 and location 3 using your ruler. The other option is that if you look in the class Google Drive, you will see that there is actually a PowerPoint document which contains this exact diagram. And so all you have to do is you just have to link the layers together. So you can see here's the spearfish. So we can link the bottom of the spearfish here to the bottom of the spearfish there. And then we can do the same thing. Oh, didn't want to do that. And then we can do the same thing for the top of the spearfish. And we can link it from there to there. And there we go. Then we've correlated the spearfish. Okay. And so in the case of using the PowerPoint diagram, you can see that each of the stratigraphic columns are next to each other on just one slide. So it's going to make that correlation a little bit easier to do. Now, for the 4 stratigraphic columns, what's going on? Well, first of all, you'll notice on the left-hand side of each of them, there is the geologic timescale noted. It goes from Precambrian all the way through to the Quaternary. You will also notice that each of the different periods is represented by a different color. So the Cretaceous is clearly green, the Tertiary is orange, the Pennsylvanian is this kind of slightly minty green color. And so that allows you to visually track the 8 rocks of the same age between different locations. So we can look, here's this Pennsylvanian rock here, Pennsylvanian rock there, there, and there. So it gives you some idea where the layers of rock are going. Now, one of the things you may notice, and if we go back to the spearfish for a second, you will notice that the spearfish layer actually contains two colors. We have blue and we have this kind of gold color. And this is because when the spearfish was being deposited, there was a transition from one period to another. So half of the spearfish layer is formed in the Permian and half of the spearfish layer formed in the Triassic. Doesn't matter. The whole thing is still considered to be the spearfish. So you don't have to correlate this contact here, okay? That's not important. We are simply focused on the lithological contacts, so the contacts between the different layers of rock. We don't really concern ourselves with the age. Now, the nice thing is that for each of these 4 locations, they have been logged and the names for each of the layers are provided. And so that means at location 1, you can see right here's the, well, for the Jurassic, we have the Gypsum Spring Formation, the Sundance Formation, and the Morrison Formation. Then we move to location 2. There they are again, Gypsum Spring, Sundance, Morrison. So you don't have to worry about which layer correlates because, as you can quite clearly see, they are labeled for you to make the job easier. Now, one of the things you're going to notice, though, is that as you move across, some layers will appear or disappear. And so, you know, for instance, if you're looking at this package of more thinly bedded Cretaceous rocks here, you will notice that as you move from location 1 to location 2, one of those layers of rock is not going to be there when you make it to location 2. So clearly it's pinching out as you go from location 1 to location 2. I would also like to point out that at location 3, you can see the stratigraphic column actually looks quite big compared to the other 3. And that's because you will notice that the Silurian and Devonian have made an appearance. Look at the other 3 columns. On the other hand, the Silurian Devonian is not present. So watch out for these changes. So once again, just like question 1, you are going to be correlating these layers together. So you're going to link the tops and the bottoms for each of the layers at adjacent locations. So you'll link the Sundance at location 1 to the Sundance at location 2. Then you'll link the Sundance at location 2, the Sundance at location 3, and then location 3 to location 4. And once again, you're going to link together the layers which you can do most easily first. And then once you've done that, you are going to end up with a whole load of these triangles appearing. And that once again is going to show you the layers that are thinning and pinching out between locations. So then as we move down, we are going to go to question 3. So question 3 asks you which geologic periods are missing from the stratigraphic column at location 1. So just look at the left-hand side of the stratigraphic column for location 1. Look at the geologic timescale here and say, right, which period or periods are not present. Then with location 4, it's going to ask you which stratigraphic columns suffered the most erosion during the Paleozoic. That's an important point. Paleozoic, not Mesozoic, not Cenozoic. We are focusing exclusively on the Paleozoic here. And so how do we see erosion in stratigraphic columns? We see erosion having occurred due to the lack of layers of rock. So what you are going to look for is you're going to notice that one of the locations is going to be missing quite a lot of the Paleozoic aged rocks. And so that's obviously going to be the location which has suffered the most erosion during the Paleozoic to destroy those rocks. Okay, so that's it for part 1 of the lab exercise. So I think this would be a good time for you to get up, have a walk around, get yourself a glass of water, and then please come back for part 3 of this video, where we will be looking at part 2 of the lab exercise.